All right, welcome back. We're going to solve this equation algebraically over the domain 0 degrees to 360 degrees. Next, then we're going to verify and then state any MPVs. Now, one thing to note, and this is how we're going to trick you, it does not have an equal sign there. So that might matter, might not. We'll see. Next, looking at my equation, the left side does have a cosine squared, so maybe we'd be tempted to put some kind of trig identity in there, but I think this cotangent x is more of a concern. So I'm going to actually substitute in an identity for that, which is cosine x over sine x. Now we still have this multiplied by sine x. And what we're going to see is the opposite of dividing by sine x is multiplying by sine x. So we're left with a cancellation. And on the left side, we still have cosine x squared. And on the right side, all we have left with is cosine x. So now I'm going to make one of the sides equal to 0. So cosine x squared, I'll subtract cosine x from both sides. Now I have a common factor of cosine x. So I'm going to factor that out. And I'm left with cosine x minus 1 equals to 0. Now we're in that situation where I have two cases or two factors that I can make equal to 0. So the first one is cosine, where cosine x is equal to 0. Now off the unit circle, that happens in two locations, where x is equal to 90 degrees and 270 degrees. The second situation that we have is where cosine x minus 1 is equal to 0. So I'm going to add 1 to both sides. And we're looking off the unit circle. Now this is where we're going to be careful. This occurs when x is equal to 0 and at 360 degrees. But we already talked about that in the domain, well, it doesn't equal to 360. So we actually only have that one answer. All right, next. It says verify your solutions graphically. I'm going to let you do that. So you're going to want to make our right side equal to y2 and our left side equal to y1. I'll give you a moment to do that. Check your answers. And you should have realized one of our answers is wrong. And we're going to check right now why that is. We're going to state any MPVs. So if we go back and look, it's not as obvious in the initial equation where it might occur, but in our first line that we did, we have a division by sine x. Well, you can't divide by 0. So for C, we need to find out, well, where is sine x equal to 0 then? Well, that actually occurs in one spot based on our, or two spots based on our domain. So that happens at 0 degrees and 180 degrees. Uh-oh, we got a problem. That matches. So actually our answer from A is incorrect. The answer from A really should be x is 90 degrees and 270 degrees. And then our answer for C should be NPVs are 0 degrees and 180 degrees. All right, on to the next question. So determine the general solution in radians of this equation. So a little different, we have general solution. We've seen that before. Don't let the square root of 2 scare you too much. The first thing that I see is that I've got a double angle identity. So then looking at our identity sheet, we can see that it's equal to 2 sine x cosine x is equal to square root of 2 times cosine x. Now I'm going to subtract, make one side equal to 0, so I'm going to subtract square root of 2 times cosine x. So then I'm left with 2 sine x cosine x minus square root of 2 times cosine x, all equal to 0. I have a common factor of cosine x, so I'll factor that out. And I'm left with 2 sine x minus square root of 2, all equal to 0. Now we're left with two cases. So our first factor, where cosine x is equal to 0, and that occurs in two places, where x is equal to pi over 2, and x is equal to 3 pi over 2. Our second case that we have to worry about is 2 sine x minus square root of 2 equals 0. Well, I'm going to add square root of 2 to both sides and divide by 2. So I end up with square root of 2 all over 2. And looking at the unit circle, we can see that that occurs in two places. And so that's where x equals pi over 4 and 3 pi over 4. Now we're not done. This asks for the general solutions. We're going to do the right case first. So these ones aren't 180 degrees apart or pi apart. So we're going to write them as separate general solutions. So pi over 4 plus a full rotation. So 2 pi n. But make sure, again, we need a full rotation, so n must be an integer. And the same for 3 pi over 4. Its coterminal arm is a full rotation away. So n must be an integer as well. Now we take one moment to just kind of think about our left-hand solution. We'll see that pi over 2 is up here, and 3 pi over 2 is down here. Well, those are 180 degrees apart. So I could write them as two solutions, but I could also write them as pi over 2 plus n pi, where n is an integer. So now we've answered the question. Right, our final equation. Algebraically determine the general solution in radians. Use reciprocal identities. So a little bit of a hint there. So the only identity I could use that's a reciprocal is right on this cosecant x. So I'm going to leave the left side alone. So 2 sine x equals 7 minus 3. Now, cosecant x is actually 1 over sine x. So therefore, it's going to be 3 over sine x. Now, this is a little bit of a different situation than we've been in. 7 doesn't have a sign where I could factor it out. And it doesn't appear there's any identities I can use. So I actually need to get rid of this divided by sine x. So I'm going to multiply everything by sine x. So then my first term, 2 sine, becomes 2 sine x squared. 7 times sine x. And now this sine x cancels out with the other sine x as a multiplication. So we're just left with minus 3. From here, I'm going to make one side equal to 0. So I'll leave the sine x squared on the left side and subtract 7 sine x and add 3, which is all equal to 0 now. And this one might be worth actually substituting in a variable. So I'm going to let a equal sine x. I'll put let. So then I can rewrite it as 2a squared minus 7a plus 3, all equal to 0. So this is PSA 2 factoring, looking for a product of 6, sum of negative 7. So I'm getting answers of negative 6 and negative 1. So then splitting apart that negative 7 into minus 6a and minus a, we still have plus 3 equals 0. Okay, so then I'm going to do some grouping. My GCF in this group is 2a. My GCF in this group is negative 1. So those GCFs will form one of my factors, so 2a minus 1. And then whatever the division becomes will be the other. So 2a squared divided by 2a is a. And the negative 6a divided by 2a is minus 3. All right, so at some point we need to substitute back in the sine x. So I'll do it right here, and I'll actually do it with my cases. So 2 sine x minus 1 is equal to 0. So we're going to add 1 to both sides and divide by 2. So then we need to look on the unit circle. Where is sine x equal to 1/2? Well, that occurs at x equals pi over 6 and 5 pi over 6. Our second case occurs at where sine x minus 3 equals to 0. We add 3 to both sides. Now there's no solution here. So remember that sine only has a domain of negative 1 to 1, and this doesn't fall in it. So let's go look if we answered the question. Determine the general solution in radians. Okay, so general solution, we are in radians right now. So neither of these solutions are actually 180 from each other. So I'm just going to write them out separately. So pi over 6 plus 2n pi, so a full rotation, where n is an integer. And then we have 5 pi over 6 plus 2n pi, where n is an integer as well.